Hi, everybody. We are here today for another talk. And today I'm very excited because we are talking not only to a scientist, but also someone that it's a elite athlete. He's been running for very long. He's been a world champion in sky running, and he's been doing studies in the Glacier. So today I'm very proud to talk with my friend Pascal Egli. Hi, Pascal. How are you doing?
Hi Kilian, thank you. I'm doing well here in the mountains, and I hope you're well too.
Yeah, doing good. Yeah, it's a strange year. It's we has been living a strange period with all the COVID and but it's been a good year for you too. Like you has been finishing your PhD, so I believe that that's something something huge.
Yeah, actually, I'm still working on finishing it, but yeah, recently we published an article, so yeah, I took let's say took advantage of the situation to work more on that for sure. Yes.
Yeah, and for people that they don't know you, they probably know you as an athlete because, as I mentioned, like you has been accomplishing some very big races. Like you won the sky running World Series. You've been in the podiums on all the like let's say 22 marathon distance on mountain races for many years. But not many people know about your background as a scientist. So can you tell us about what are your studies and what are you doing the research on?
Sure, yeah, so originally I've been trained, I studied environmental engineering in two different universities in Switzerland, and but then I have always been interested in understanding better how the mountain environments and especially the glaciers function, how just the process in nature function. So I decided to do a PhD. That was almost 5 years ago already now at University of Lausanne, and we study how the water flows below the glaciers. So all the water from supraglacial melt, how it is transported in channels and small voids underneath the glacier to the glacier outlet. Yeah, that's what we have been doing most of the time in these years. But then also during my PhD, I also contribute to teaching courses, and we do a lot of field work. So we collect data on the glacier. But now, because I'm in the end phase, I'm mostly writing up results and yeah, wrapping up the work.
That's a lot. I think that's harder than training for sure. That it's more hours and probably more intense hours than training for doing sky running. But actually, when we talk about glaciers, I believe that many people it's thinking just okay, yeah, they are beautiful, they are in the mountains, but they have no use. And I believe that that's different. I think the glaciers they have they are important. They are an important ecosystem. Can you tell us about that?
Yes, I mean, glaciers, they have so many functions because, let's say, first of all, maybe they're like a reservoir. So they're storing water for us. For example, I mean, during winter, they accumulate a lot of snow usually, and this snow and ice, so snow after 1 to 2 years, it transforms into ice. This is available then in summer when there's a long dry period, because in summer is the period when it melts. And so it's constantly storing water and releasing water. But then there's many other functions, of course. It regulates the local climate. Then it has an impact, a big impact on ecosystems, alpine ecosystems, but also subalpine, like in the alpine streams. And of course, it's also a visual aspect. For example, when you go to the mountains and they're only gray without glaciers, it's a very different scenario.
Yeah, that's sure, and it's been changing a lot. Like over the years, we've seen that the glaciers has been getting smaller, and that affects also the practice. Like you are also an alpinist, you are a skier, and have you seen like how it affects this melting of the glaciers when you go practicing an activity in the mountains?
Yeah, I mean, in the recent years, you have probably also seen, for example, in the end of summer, there's barely any snow left on the glaciers. So one thing is that even easy alpine routes, because the crevasses are not covered well in snow anymore, they have become very difficult. because the access even onto the glacier can be dangerous. It can be steeper. Then passing the crevices can be difficult. On the other hand, there is more rockfall because there's less permafrost, so the frozen rock holding together. There is, many diverse effects, even in winter, I would say, because, we have had recently in February, it was very warm again, like the past few Februaries, I think, as well. I think that's some major impacts. So the whole mountaineering and ski mountaineering, I think many routes, they transform a lot. Yeah.
Yeah, so we need to change when we go. Probably activities that we were doing in August, now we need to do in July or even in June, because the glaciers and the morphology of the mountains are changing. And as you mentioned, like the permafrost, it has a big impact, because like with these landslides and rock falling, like it's just making the mountains more dangerous somehow. And probably that's something that when you study in the glaciers, it's things that we can relate, because many times when we are reading papers, we think that it's something that it don't goes with us, like it's something that it's for science, but it don't have an impact to our lives. And I believe that many of the research is important, because at the end, the findings, they can have an impact on our lives, on the life of the planet, and even on the activity that we are doing out in the mountains. So you are very up to date about the glacier research. So what's the state of that? Like, why is important the glacier research, and what are you investigating, you and your colleagues?
Yeah, so I mean the impact is very direct. For example, during our studies on the glaciers, so our fieldwork, we witnessed ourselves how like a big part of a subglacial channel, it just broke down, because what happened is usually the glacier is just melting at the surface, but now this channel melted out from the inside, and because the surface got so unstable, a big chunk of more than 50 meters in length and 10 meters in width, it just broke down. So we realized some of the melt is going actually much faster than we expected in some locations, not everywhere, and in some periods. And what we measured in the field is, for example, this glacier, we can see it also for other glaciers, it recedes by like 40 meters a year. And the state of research is now is that the most small to medium glaciers in the Alps, they are going to be almost completely gone by around 2070. And even the bigger ones, they're going to be gone by around 2100. So that's what the modeling says, but also the measurements, they confirm it. For example, if a model was run 20 years ago to predict how it is now, this is pretty accurate when we measure it now, or sometimes the retreat is even a bit faster. And then what you mentioned on a global scale, I mean, obviously what these glaciers provide is drinking water for hydropower, and in Switzerland especially we rely a lot on hydropower, like you in Norway. And actually also the future energy strategy of Switzerland is relying heavily on hydropower, but it needs to take into account that these glaciers are disappearing. So there will still be rainwater and melting water from snow, but much less melting water from glaciers, especially in summers. And that's a big impact that is going to occupy us for the future, yeah.
Yeah, that sounds very fast. Like it's like 100 years to the glaciers to disappear. That's our generation or the next generation. It's something that we are witnessing with our race, and that feels scary in a way. And as you mentioned, like it's water. It provides water, and I think like countries like India, they rely a lot on the Himalayan glaciers. And as you mentioned, like in Switzerland or here in Norway, it's a lot of hydropower, so also the energy. So we see that glaciers, the impact that they have is not only in the areas where the glaciers are, but it goes beyond with water and with power. And I believe that also with the melting, it's accelerating the global warming with the albedo. Probably it's less albedo surface, so it's just growing the global warming. And I think I read some studies about like the glaciers that they are covered by rock. So it's still a glacier that it's alive, but it's just covered by rock. So probably then the melting is also faster.
Yeah, that's a very important thing you mentioned, these feedbacks, right? That's very important in climate science, that we have some feedback loops that can go one way or the other. Either you have a positive or a negative feedback, and a positive feedback can reinforce the process, so it can make climate change even stronger, or a negative feedback can make it maybe slow it down a bit. So, for example, as you mentioned, the albedo, so it's the reflectivity of the surface. Usually, because a lot of ice surface melt, we have less bright surfaces that are white that reflect a lot of sunlight, and that means that less energy is reflected back to space, and it means that more energy stays in the Earth's surface, and so heats up the atmosphere even more. So this is one of the consequences of glacier recession and ice sheet recession as well. But also even the snow cover, right? Like, for example, on the northern hemisphere of the Earth, we have less and less duration of snow cover in winter. If you think of whole of Siberia and whole of northern Europe and all, and this has an effect, also a feedback. Then the other thing you mentioned is interesting, the debris cover, right? Because if a glacier is covered by a lot of rocks insulating the glacier, it can make the glacier recede more slowly because it's insulated, but also due to the rocks, the glacier's albedo is much lower, so it's reflecting less. It looks like bare land, and it can heat up the atmosphere more. And yeah, as my one friend of mine who published this study about the state of rock glaciers in the world, it's showing that it's going to increase heavily with climate change, most probably. And so maybe it leads to slightly slower glacier recession, but more lower albedo, so more warming of the atmosphere too.
Yeah, the picture is not nice. Like I don't think we have a nice panorama in front of us. But so with the research you do, like probably if we start to take action, we can probably reverse or slow down this process. But what's gone already? Like probably one big part of these glaciers will be gone, no matter which action we take now.
Yeah, that's true what you say. I mean, it's true that the modeling, the results are not very optimistic because, I mean, there's a big delay between what we do now, the emissions we do now, and what happens to the atmosphere temperature. So even if we stop emitting anything now, the temperature will still go up of the Earth's surface by more than 1 degree probably. And then even more delayed is how the glaciers react to it, right? Because the glaciers are always a bit delayed because they don't only depend on temperature but also on precipitation, and it takes a few years for them to react to a temperature change. So actually, I would say if we're very conservative, we're really careful about our climate emissions and we follow, let's say, the Paris Agreement or even better, then we will at least have some, let's say, by the end of this century, we'll have some smaller parts of now still big glaciers, like Aletsch Glacier in the Swiss Alps or otherwise in the Alps, will still be left. So there will still be some parts left, but if we don't follow these recommendations, then there will be almost nothing left. That's basically the the scenario.
So we need to take action, and probably we need to start taking seriously, because it's not that if we change action today, tomorrow we will see a change in the ecosystems and in the glaciers, but it will take some time. So I think we need to understand that our action today, it will probably affect the next generation on the good side or on the bad side. So going on that, and probably with all your background, like what are the things that we can do as first as athletes? Like you are an athlete, I'm an athlete, and most of the people that is listening, they love to be outdoors, and we have power. I believe that as individuals, we have some power to change things and to influence. So what would be your tips or your your advices for all of us.
Yeah, it's good you say we have power, because I think we have more power than we think we have. Although some people, they feel a bit almost pessimist because they think they have no power. But first of all, of course, we can change our own behavior, and it's similar according to, for example, the auto-friendly pledge, right? So we can try to reduce our travel or travel differently. Say I only take maximum, I don't know, 1 or 2 flights a year, which is still enough, I would say. Then travel less by car, and more by public transport. Or, well, let's say instead of a gasoline car, we can try to use an electric car. But then there's many other things like, for example, how we eat. I think it's very simple, or consumption, right? If you go to the shop, because just think about what you buy, or if you really need to buy something, and that way you can maybe even save money, right? For example, you decide to eat half the meat you used to eat, but then another thing I think is voting, right? Is how you vote in politics, and talk to other people, because I realized that although I'm maybe not always consistent, no one is perfect, but by talking to people, maybe in the beginning they're a bit skeptical, but you can influence them a lot and make them think for themselves. And and then of course, but as an athlete, we can try to do more things more locally, and I think Corona now teaches us that we can actually explore our playground at home a lot, right? There's so many nice local races, local interesting mountains projects we can do just starting from our home. For example, just last weekend we did a long traverse starting from home, basically, that I had never done, and I wondered why. Yeah. So that's some ideas.
That's an important thing, like to understand the backyard. And talking about the backyard, like when you go to the glaciers, what looks when you go to study the glaciers? What's your journey when you do you go to the glacier, you take samples, and how does it work?
Yeah, cool question. Well, we usually actually camp for quite a few days up there, and it's not so far. It's Otema Glacier, so it's on the border to Italy, and we camp there. Then usually we get up quite early because we want to avoid the thunderstorms in the afternoon. We get up maybe at 5:30, 6, and then for example, what we did, we measured a lot of lines with our radar antenna. It's an antenna that you carry on the backpack. So we basically set up our differential GPS, a very precise GPS system, to log our position to like 2 centimeters precision. And we walk back and forth on this glacier surface with the radar antenna in a very precise pattern. Then on the same day, some maybe other students who help us, they do a drone flight over the glacier surface to have the precise topography and aerial imagery. And we also measure, like by hand, we measure ablation stakes. So we measure how much the ice melts every day. And it's quite impressive. You measure every day, for example, on a normal summer day, they melt 7 centimeters. The glacier melts down, yeah. That could be a normal day, but then in the evening you spend a lot of time recharging devices, cooking, planning the next day, and maybe if I have time I go for a short run up the steep slopes there. Yeah.
That sounds pretty fun, actually.
Yeah.
So it looks like you are in a good place, like just surrounded by nice mountains, and just doing, like, studying the nature. That it's what we love.
It's true. It's very beautiful. Also because where we work, there's no cell phone network, and it's very secluded. Like it could be somewhere in Karakum or something, but it's not so far from home. And it's beautiful to be all the time outside in the tent and never in a house. And sometimes it can also be a bit stressful. Let's say if a measurement doesn't work, or a device, you don't find a software error or something, or you need to charge something and there's no more battery, and but in general it's really much fun. I agree. So I think it's the easier part than working at the desk and trying to code up your results. Yeah.
Yeah, and these talks are for athletes, and these talks are for athletes to understand environmental science. And you are the perfect mix. You are an athlete. You has been an athlete for long. You has been an elite athlete, and you do science. So why, as athletes, we should care about science? Why we should think that it's important that we invest and that we read science, that we get up to date, and that we care on science and on environment on a scientific level?
Yeah, I would say especially, well, both as a trail athlete but also as a winter athlete, we are very much influenced by the environment we practice our sport in. And if we don't take care of it, I think in a few years it won't be the same at all. And I see us very much as part of the ecosystem, right? We are not just humans and nature, but we are part of it. And probably also because we think we're the most intelligent beings on the planet, I think we have a certain responsibility to take care of it. And yeah, I mean, we come in our playground where we train, we're completely dependent on this playground. And I think now, if things turn really bad with climate change, it won't be the same playground anymore. And yeah, I think it's for the love of what we do, I would say. Yeah.
Yeah, I think that's a very good message. Is because we love it, we should to take care, and to take care is to understand how it works. And that's the scientists that are telling us what's happening and how we can act, all of us. So thank you very much, Pascal, for enlightening us about glacier science, and hope to see you soon on some races.
Yeah, thanks to you, Kilian. It was really fun to talk about this with you. Yeah, hope to see you soon too, on a mountain or a race.